Welcome to Physics with Mr. Brazil. We're looking at gravitational forces between three masses. We're going to have an angle this time because this is at right angle or 90 degrees apart from each other, these masses. Before the video that I have, it's horizontal or it could be vertical, straightforward. We have no y components involved. But this time we're going to have some y components. So we're going to have to use component vector math. So here we go. First of all, we're going to need to get the distance between the 4 and the 5. Well, that's just Pythagorean theorem. Okay, so let's just do that. 4 comma 5, that's just going to equal 3.0 meters squared plus 4.0 meters squared, and I'm sure you know this is the common 9 plus 16, 25, so square root of 25 is 5 meters. Okay, so this has a distance of 5 meters. Good, we now have the distance for our gravitational force for R, but we also need this angle, so we're going to need to calculate our x component, and we're going to need to calculate our y component, and theta will be right here, so this is the I. Okay, so now we can figure out our trig functions. So theta is going to equal arctan, and 3 is going to go on top, 3 meters, 4 meters, and that's going to give us an angle of 37 degrees. Okay, now we need to calculate the forces, okay, between each. So we're looking at the 4, and if we were to unpin it and it's facing the 3, or 3 is above it, what direction is it going to go? All right, it's going to go in a positive direction. We don't need to put the negatives and positives because we could just take the angles into account. But for now, it's going up, so it's a positive direction. So this is FG 4, 3. Okay, it's going to be G, M, I'm going to call it 4, 4, M3 over, I'm going to say R3 squared. So let's put some values in, 6.67 times 10 to the negative 11 Newton meter squared, kilogram squared, times 4.0 kilograms times 3.0 kilograms all over 3.0 meters squared. And that's going to give us 8.89 times 10 to the negative 11 newtons. Okay, that's great. Now let's tackle the 4, 5. So 4, 5, that's going to be G, M4, M5 over R5, I'm going to call it squared. Put our values in, 6.7 for G times 10 to the negative 11 meters second, not second, kilogram squared. See, we get caught up in our forces of gravity, but this is gravitational force. Universal gravitational force, so 0.0 kilograms times 5.0 kilograms all over 5.0 meters squared, and this is going to be 5.34 times 10 to the negative 11 newtons. Okay, now we have our forces. Now we can apply our components. I'm going to make this a little smaller to make it a little more comfortable to do the math. See if I can get my square, because I got to get it to encompass everything. I'm going to make this smaller. Okay, so that we have some room. Okay, and I'm going to do this in black. Now I'm going to find my components. So write things out, no shortcuts, all right? no shortcuts. So write x comp, y comp, okay? No shortcuts, write things out. So this is going to be fx, 4 comma 3. Well, cosine of 90 is 0, so there is 0 force in the x, okay? But in the y direction, 4 comma 3, well, there is a force, and fortunately it's sine 90, so it'll just be 8.89 times 10 to the negative 11 newtons. Okay, no problem. That was pretty easy. But now let's tackle the 4, 5. Well, fx 4 comma 5 equals. So we have our gravitational force, and it's positive because it's going to the right and up. But if it was in a lower quadrant, then we take into account the negatives, but in this case positive. So 5.34 times 10 to the negative 11 newtons. And this will be cosine 37 degrees. That answer is going to be 4.26 times 10 to the negative 11 newtons. All right? So now let's tackle Fy, 4 comma 5. Okay, and this will be the 5.34. And again, this is positive because it's pointing upward. Newtons sine 37 degrees. And this also will be 3.21 times 10 to the negative 11 newtons. Okay, so now we need to sum this up. I'm going to bring this up a little bit. All right, so let's sum these. In this case, the sum of x is just 4.26 times 10 to the negative 11 because it's just adding to 0. But not so here. So we're going to need to add this number here to the number below. So the net forces in the y direction will be those two summed up, 1.21 times 10 to the negative 10 newtons. Ooh, there's a little more force upward. Okay, well, let's calculate our net force. I'm going to bring this up again. So our net force, or resultant force, is going to be the square of the net plus in the x direction and the square of the net in the y direction squared, square root. So Pythagorean theorem, never can get away with it. So, or away from it, 6 times 10 to the negative 11 newtons, square it, plus 1.21 times 10 to the negative 10 newtons, square that also, square root, and this answer is 2 sig figs, 1.3 times 10 to the negative 10 newtons. So the 4 kilograms is going to experience a 1.3 times 10 to the negative 10 Newton force upward. But what direction is it going? Because the 3 is tugging on it and the 5 is also tugging. So we're going to have to do theta equals tan, arc tan, negative 1. Okay, so let's put our y direction above, 1.21 times 10 to the negative 10. We'll put newtons, divided by the 4.26 times 10 to the negative 11 newtons. And that's going to give us an angle to 2 sig figs, 71 degrees. So how would I answer this? I would write the 4 kilogram mass will experience a 1.3 times 10 to the negative 10 Newton force exerted at 71 degrees. And we're done. Okay? That's how you solve these. And you're going to have to use your quadrants, okay? So if the force is below, so if we were looking at the 5, okay, and if we got the force on the 5, we're going to have an angle going in this direction. So we're going to have sine is negative, cosine is also negative for force on 5 on 4, okay? So in the case of the 5 on 3, it's just going to be going to a negative direction to the left. All right? Keep practicing physics. If you need to review this, slow it down and go through it again. All right? Enjoy. Bye.